అవును. Just wait for 1 minute. Oh, Bhavani, just wait for 1-2 minutes. Okay. Okay. Hello. Okay. Sorry for delay. The average of two random samples of size 16 and 11 are 292.5 and 2259.5 respectively. The sum of squares of the deviation from their respective means are 37.7 and 28.6. Can you conclude that the two samples have been drawn from the same normal population? Given that n1 is equal to 16, n2 is equal to 11, x bar is equal to 292.5, y bar is equal to 252.9. So summation of xi minus x bar whole square is equal to 37.7 as given here. The mean is given here. Yi minus y bar is equal to 28.6 so whole square is given here. So the null hypothesis, two samples have been drawn from the population Vx is equal to Vy. Alternately, the two samples have been drawn from the same population Vx not equal to mu y. So summation of I is equal to 1 to n1 xi minus x bar whole square. Summation of j is equal to 1 ni yi minus y bar whole square n plus n2 minus 2. So 37.7 plus 28.6. So we are evaluating here 6 plus 16 plus 11 minus 2, that is 2.652. S is equal to, so S is equal to say 1.628 in the given the 1.628 under HO statistics x bar minus y bar. Bhavani, you are listening? Bhavani, you are listening? Respond, please. Tell me the answer. Tell me the answer. So therefore x bar minus y bar s bar root of 1 plus n1 plus 1 by n2 values తీసేస్తున్నాం 292.5 minus 25 252.9 1.6 and 1 by 16 plus 1 by 11. So therefore t calculated value is equal to 62.10, that is degrees of freedom 2.60. This is one example. You have to see and tell me what is correct or not. Fast. The following data is the breaking strength of the steel cables in cages produced by two different processes in a factory. They wanted to know whether the steel cables produce a difference in their average breaking strength between the two processes. Set up null hypothesis. There is no significant difference in average the strength between the two processes mu x is equal to mu y. There is a significant difference in the average breaking through between the two processes mu x not equal to mu y. So it's not 2232, 2274, 2470, 2458, 2262, 2318, 2258, 2334, 2382, 2266, 2162, 2278, 2298, 2214, 2258, 2230, 222278. So therefore, తీసేస్తున్నాము dixi minus ha. So summation of dx. Dx is equal to x minus a by h. So dx is equal to x minus a by h. See here, summation of dx is equal to minus 18. This one total minus 18. So taking the d of x minus a by h, we are taking here. So dx is equal to minus 18, arbitrary value 2350, 2250. So therefore h is equal to 4. So ax dx by into h. So we are evaluating the same. So 2342 y is equal to b plus summation of dy into k 2245.1. Sx square summation of dx square by n summation of dx whole square by n into h square 512. Sy square summation of dy square by n summation of dy whole by n whole square into k square is equal to 191.2. S square is equal to n1 minus 1, sx square, n2 minus 1, sy square, n1 plus n2 minus 2. So therefore, n1 means total 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is also 9, both are 9. We are taking here 9, 9 minus, so both are 9, 9 plus 1, 9 plus 9 minus 2. So 9 minus 1, 5 into 12, 9 minus 1, 9, 9 191.2. That is S is equal to 25.4 under HO. The test statistics is given by x bar minus y bar by S under root of 1 by n1 plus 1 by n2. So that is 25.14 by 1 by 9 into 1 by 9. That is 3 is 8.18. So see here in the problem we are taking the value of x minus a by h. Then y minus b dx square. 7 squares are 49, 19 squares are 361, 30 squares are 900, 27 729. 22 484, 88 is 64, 23 529, 416, 864 total. This is total plus and minus are minus 18. This is plus and minus are minus 11. That is now y square is equal to 901. We are applying 3196 and 901. These values are substituting in the above equation. Paid sample test. Paid sample test is used to management to see whether the advertisement campaign was successful or not, the effectiveness of training program in the organization, etc., and the clinical trials to ensure newly developed drug effectiveness, etc., and so on. In the previous test procedure, the samples taken from populations are independent, but sometimes it is possible to collect information from the sample individual or customer before and after some experiment. Then the scores of individuals become dependent on each other. So when there are two samples and are dependent, paired sample t-test is used to is there any significant difference in the average score from of characteristics of interest before and after the experiment? Let xi, yi is equal to 1, 2, 3, 4, and so on n. So be the scores is individual before and after an experiment instead of t-test for difference of means. Here it is used to pair the sample of t is difference in the sources. The scores are we are taking here before and after experiment di xi minus phi is significant or not. So set the null hypothesis, the difference in the average score between the before and after experiment mu x is equal to mu y. So the difference in the average between before and after experiment is not the same. Mu x not equal to mu y. So to test the hypothesis, the test statistics is given by d bar by s by under root n, d bar by s by s root n, where d bar by 1 by summation of di. So s square is equal to 1 by n summation of di minus d bar whole square follows the distribution of n minus 1 degrees of freedom we are taking here. Rejection rule. If calculated value of t is less than a critical value of t at alpha percent significance level with n minus degrees of freedom, then who did not reject HO, otherwise we reject HO, and we conclude that there is a significant difference between the two population means. Example, one example we have to take here. The president of a company in the process of deciding whether to adopt a yoga program. The purpose of such programs is to improve the health workers so that medical expenses are reduced. To get more information, he initiated an exercise program for the employees of one of his plants. The president knows that during good weather, medical expenses are relatively high because of seasonal influenzas. So consequently, he decided to use matched pairs designed by recommending medical expenses for 12 months before program and 12 months after program. The medical expenses are given below. So January, February, March, April, May, June, July, August, September, October, November, December. So we are taking here these values here before and after we are taking here. To the data, so above the data is indicate the yoga program reduces medical expenses at 1% significance of level. Solution. Let X and Y be the medical expenses before and after the yoga program respectively. That's the null hypothesis we are taking here. The yoga program does not medical expenses, that is mu x less than or equal to mu xy. The yoga program does not raise the medical expense mu x greater than mu y, that is one tail. So here the given 82, 58, 44, 72, 49, 47, 66, 83, 66, 44. Tata Rasa manam D into X minus Y. See here, 82 minus 67, 15. 50 minus 58, 5. 44 under 16. It is 2. 33, 16. 47 minus 38, 9. 64, 2. This is 70 plus 13, 83. 33 for 17, 83, 83, 0. November 48 and 14, 34 means 44. See, this is taking the values. So therefore, after 16, before x and after x, we are writing here x minus y. We are treated here the values. So di minus d, di. This is my di minus d. This is 15. What is di? We are taking it under control. Di means 109. Total x 1 by n, 1 by n, 1 by n, 109 by 2. That is 10.8. So 9.8 we are removing. 15 minus 9.8, 5.9 to 15 minus 15. So once we can check here. 15 minus 9.8, how much? 5.2, 5.92. So 15 minus 9.08, we are taking that is 5.92, correct. Then 8 also same. 5.8 minus 9.08, 16 minus 9.8, 7 minus 9.8, 16 minus 9.8. All these values of the total dx 109. So we are d minus d8. So whole square is equal to 5.92 is equal to, we are doing a 5.92 into 5.92, that is 35.0464, 05, 35.0464 means 6 is 35.05, almost also 1.08 into 1.02. All these values are 380.92. This is s square. S square is equal to 1 by n minus 1 summation of di minus d whole square. 380.92 minus n is total 12 values of January to December. So 34.63 under s. Under HO, the test statistics is given by T is equal to D bar S by root N, 9.08, 5.88 by root 12, that is 5.3 by T calculated value 5.35. The critical value of T at 1% significance of level tail with 11 degrees of freedom, 2.718 we are taking here. So another example we have to take here, even 11 students were given in a test statistics. For 25 marks, they were given in extensive coaching, and second test was held at the end of it. Do the marks given evidence that students have been benefited by this coaching? Test at 1% level of significance here. See here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 23, 22, 20, 19, 21, 18, 20, 18, 17, 23, 16, 19, 24, 19, 22, 18, 20, 22, 22, 20, 30, 23, 20, 18. So let x and y be marks in statistics before and after the extensive coaching respectively set up the null hypothesis. There is no significant difference in the marks before and after coaching mu x less than mu y. There is a significant difference in the marks before and after coaching mu x greater than mu y is one tail. So here so 23, 20, 19, 21, 20, 18, 20, 18, 17, 23, 16, 19. Then y is equal 24, 19, 22, 18, 20, 22, 20, 20, 23, 20, 18. They are given here. So dix minus y, 23 minus 24 minus 1, 20 minus 19, 1, 19 minus 20 minus 3, 21, 18, 3, 18, 20 minus 2, 22 minus 2, 18, 20 minus 2, 17, 20 minus 3, 23, 23, 0, 16, 20 minus 4, 19, 18, 1. Total dx minus y minus 12. So di minus d bar 0.09. So di minus d bar means 1 by, that is minus 12 by 11, total 11 minus 1.09. So therefore minus 1.09 di minus 1 minus 1 plus 0. Minus 1 plus 1.09, that is 0.09. Then 1 plus 1.09, 2.09, minus 3, 1.09, 1.01. All these we are calculating, then 0.09 wholes. So di minus d whole square, what is the value of 44.91? So that is, we are taking x square by 1 minus n minus summation of di minus d whole square, 44.91 by 11 minus 1. So we are taking 4.49. So 4.911 S is equal to 2.212 here given here in the values are 2.212 S is taken here. So S square is equal to 4.49 is under root of is, so the S under root of 4.49 is equal to 2.12. Under HO the test H is equal to D bar S by root n minus 1.09 2.12 by root 11 minus 1.0 T calculated value 1.70. The critical value of it 1% significant level 1 degrees of freedom is 2.764. Interpretation. Since the calculated value of T is less than the critical value of 1% significant level for one till 10 degrees of freedom means we did not reject HO by because 1.70 2.764 less than low ఉంది కాబట్టి reject చేయలేము. Let's conclude that we are benefited from the coaching. In a certain food experiment to compare two types of infinite foods A and B, the following results increasing in weight we are observed in 8 children. Food B was modified food A after some protein. Both the foods were given in the same 8 children. What is the significance of increase in weight children between the two types of food? Tested 5% level of significance. 50, 60, 58, 59, 54, 57, 58, 9, 60, 70, 73, 70, 71, 68, 72, 72, 71. Let extent be the increase in weight of children due to food A and B respectively set up the null hypothesis. There is no significant difference in the mean increasing in weight of children between the two foods. Mu x is equal to mu y. There is a significant difference in the mean in weight children between the two foods. Mu x not equal to mu y. So రాసాం ఇక్కడ 56 నుంచి 60 70 నుంచి 71. సో 56 మైనస్ 70 మైనస్ 14 60 నుంచి 73 మైనస్ 13 58 70 మైనస్ 12 59 71 మైనస్ 12 54 68 అంటే చూడండి ఇదొక 8 ఒక 6 14 ఇది ఒక 5 72 15 72 ఇది కూడా 15 59 ఇచ్చినాడు 13 ఇది 11 minus summation 1 mention summation of DA 104 by 8. So under minus 104 ఇక్కడ minus రావాలి minus 104 8 minus 1.3. So minus that minus 104 by 8 చూద్దాం ఒకసారి. minus 14 minus 13 plus 14 minus 13 plus 13 minus 12 plus 13 minus 12 plus 13 minus 14 plus 13 minus 15 plus 13 minus 2. So minus 13 plus 13 0 minus 11. So that is a di minus d whole square. That is a overall 12 we are taking here. S is equal to 1.3.1. S is equal to 1.31. So therefore under HO the test statistics is given by d under root of s by d అంటే ఇక్కడ minus 13. So d bar is equal to minus 13 by 1.31 by under root of 8. That is equal to 28 minus 28.08. So we can calculate the 28.08. The tail is the 7 degrees of freedom 2.365. So we reject HO. Why? Because calculated value is high and tabulated value is very low. So we can reject the T at 5% level of significance, two tail with the 7 degrees of freedom. Hence we reject HO. So we conclude there is a significant difference, mean increase in the weight children between the two types of foods here. So this is one unit. Another unit we have go to the today 9th unit. F test and chi-square test. The distribution student T chi-square distribution and F are derived from the normal distribution, and hence they are called derived distribution. In this chapter, we shall discuss two derived distribution, chi-square distribution and F distribution. A random variable x is said to be have a normal distribution with mean mu and variance sigma square if it has the following probability density function. F of x is equal to 1 by sigma to root 2 pi e power minus 1 by 2 x minus mu by sigma, that is minus infinity less than x less than plus sigma minus infinity to plus infinity. We know that xi equals to n mu sigma square, the standard normal variable xi minus mu n01, and the square of standard normal variate xi minus mu sigma square is chi square variate with 1 degrees of freedom. If xi is equal to 1, 2, 3 and so on, k or k independent random normal variates with mean mu and variance sigma square I, the sum of the square, the standard normal variate, summation of j square, summation of I is equal to 1 to k, xi minus mu I by sigma I square is chi square variate with k degrees of freedom denoted by chi square and pronounced as chi square. So chi-square distribution deviation we are taking here, that xi is equal to 1, 2, k and k is the independent random variable from the normal distribution we are taking here. With the mean of, already we know that mean is equal to mu and sigma variance of sigma square. We know that chi-square summation of I is equal to 1 to k xi minus mu by summation sigma I whole square, summation of I is equal to 1 to k va square. So va is equal to xi minus mu by sigma I is equal to 1 to k. So since xi are independent or random variable, so therefore vi also independent. Now the moment generating function of the chi-square is m of x square f m of summation of x k va square అనే రాసుకుంటే m of v square t of k గా మనం రాయడం జరుగుతుంది. So mva square t e t v square I integration of minus infinity t v square f v dy integration of minus infinity e t y 1 by root pi e minus v square by dy. So 1 by root pi. So after the simplification here, integration of minus infinity to infinity e tv square e power minus v square by dvi, 1 by root integration of minus infinity to infinity minus v square 1 minus 2t by 2 dvi, 1 by root pi 1 minus 2t by 2 under root of 1 by 2, 1 minus 2t whole power minus 1 by 2. mx square t 1 minus 2t whole power 1 by 2k, that is right, 1 minus 2t minus k by 2, which is the mgf. Mgf taking gamma variate parameter 1 by 2 and k by 2 with reference of this one, the uniqueness of the theorem of the mgf moment generating function. Mgf means moment generating function, summation y is equal to 1 to k xi minus mu k by sigma k whole square. So therefore gamma variate parameters 1 by 2 and k by 2. So therefore pi of x square is equal to 1 by 2 whole power k by 2 gamma k by 2 a, the e power 1 by 2 gamma square in gamma square, chi square into chi square into chi square whole power k by 2 k by 2 1 minus dx square. So after the simplification, that is 1 by 2 by 2 power k by 2 2 gamma k by 2 e power minus 1 by 2 chi square k by 2 minus 1 dx square 0 less than chi square less than infinity, which is the required probability density function of chi square distribution with k degrees of freedom. A continuous random variable x is said to be have a gamma distribution with parameters a comma lambda. It has the following probability density function. F of x is equal to a lambda by gamma lambda e of e power minus x lambda power minus 1, a greater than 0 lambda greater than 0 0 less than x less than lambda. The moment generating function of random variable x is m of x is equal to a power lambda by gamma lambda integration of 0 to infinity e power 3x of e power minus x power lambda power minus x dx, a power lambda by gamma lambda integration of 0 to infinity e power minus a minus t. So therefore x into lambda minus 1 dx, a power lambda gamma lambda by gamma lambda into a minus t lambda, that is 1 by t minus a lambda into 1 by t into a minus lambda we are taking here. So that is the from denoted a is equal to 1 by 2 and lambda is equal to k by 2. So application, the chi-square distribution is a widely used distribution. Applied statistics, some of them is given below. Test of goodness, test of independent attributes also we are taking here. One of the important application of chi-square distribution is testing goodness of pattern or distribution fitted to the given data. Goodness of fit indicates the closeness observed frequency with that of the expected frequency. To fit the data on appropriate distribution like binomial, Poisson, normal, uniform, etc. And test goodness of fit, test goodness of test of godness of fit is used. Set up the null hypothesis and alternative hypothesis. The data is fit to the distribution. The data is not fit to the distribution. To test the above hypothesis, we use chi-square test of goodness of fit, and its test statistics is given by chi-square summation of f1 naught minus fe whole square by fe. Where F is observed frequencies of P is expected frequency obtained from the given distribution to be tested. Decision rule. If the chi-square calculated value is less than chi-square tabulated value, the calculated value less than tabulated n minus degrees of freedom at alpha per significant level, then we do not reject HO, and we conclude that the data is good fit to the distribution. Otherwise, we reject HO. F1 and Fe are respectively the observed and expected frequencies of ith class such that summation of FO is equal to summation of Fe. If any Fe for I is equal to 1 to K found less than 5, the corresponding class frequency may be pooled with preceding or succeeding classes such that Fe is called all the classes greater than or equal to 5. If may be noted that the value of K may be determined after pooling the classes here. Six coins are tossed. Six coins are tossed 658 times, and are the following results are obtained: 0, 1, 2, 3, 4, 5, 6, 25, 84, 165, 179, 124, 65, 16. Test the hypothesis that the data fit to be binomial distribution. Set up null hypothesis that HO binomial distribution is a good fit for the given data. Against H1 binomial distribution is a not good for fit for the given data. In its number of coins lost for time. Let X denote the number of heads in tosses. Number of times experiments is repeated. Total 658. We are written here. Total 658. So find the mean of the distribution. Find the mean of the distribution. 25, 84, 165, 179, 124, 65, 16. So X bar F is the frequency. We are finding the distribution here. So summation of X is equal to 1868 total here. So total here frequency 25 into 0, 0. See here all of you. 25 into 0, 0. 21 into 484. 165 into 165. 2 into 165, 330. 3 into 179, 537. 4 into 124, 496. 5 into 65, 325. 6 into 16, 96. The total is 658. This total is 1868 we are taking here. So 1868 by 658 is equal to 2.84. The probability mass function is binomial distribution is NCX PX 2 by n minus x is equal to 0, 1, 2, 3, 4, 5, 6 until we are taking here. So up to 6. Why? Because only the number of heads is given 6 here. So therefore mean of the binomial distribution x bar NP is called P x bar x bar NP P x bar by NP is equal to 2.84 by 6. 2.84. This is the 2.84 here given here 2.84. 0.7 for x is equal to 0, for x is equal to 0, 6 is 0, 0.47, 0.53. So we are multiplying 1 p plus q is equal to 1. So p plus q is equal to 1 minus 0.47, 0.53. 6 is 0, 0.53. Total 6 is we are calculating the p is 0. 6 is 0 values we are counting, that is 0.22. The expected frequency x is equal to 0 n into p 0 658 is the total number in 0.002. That is the total in 0.002. That is 14.58. That is equal to 15. Using the recurrence formula, x plus 1 is equal to n minus x is equal to 1. The expected frequency at x 0, 1, 2, 3, 4, 5, 6 n minus x plus 1 6 2.50. n minus x plus n plus 1 x values should be say 6 2.50 1.33 0.75 0.10 0.17. So values are p by q and the same frequency expected frequency మనం multiply చేస్తాం chi-square is equal to f naught minus fe whole square by fe రాస్తే సో f naught అంటే ఏమి ఇచ్చినాడు ఇక్కడ ప్రాబ్లం లో 25 to 16 ఇచ్చినాడు. 1578. FE రాస్తున్నాం 50. FE ఇక్కడ తీసుకున్నాము 1578, 172, 203, 135, 48, 7. సో FE అంటే ఇక్కడ చూడండి 25 minus 15, 10, 84 minus 78, 6, 165, 7 to minus 7, 179 to minus 24, 124 to minus 11, 65, 17, 9. F naught 10 whole square 100, 636, 49, 24 and 576, 11 and 121, 7 and 289, 9 and 81. So FE naught minus 100 by 15. So ila calculate useful 6.67, 0.46, 0.28, 0.2884, 0.09, 6.02, 11.82, 8.8, 28.74. So therefore the chi-square is equal to 7.7 ఉన్నాయి 1 2 3 4 5 6 7 7 minus 1. So తీసేస్తుంటూ పోతే 5 degrees of freedom at 5% level significant 11.07. So 11 interpretation is with chi-square is greater than the tabulated value. So 5% like we have hence we reject HO. ఎందుకంటే దానికంటే ఇది కొంచెం పెద్దగా ఉంది కాబట్టి so greater than ఉంది కాబట్టి reject HO. So the binomial distribution not good for given the data. The following table shows the distribution of digits of the number chosen random telephone directory 0 to 100, 1, 1785, 2, 22, 78, 3, 15, 43, 4, 12, 90, 5, 18, 65, 6, 16, 42, 7, 1, 992, 8, 12, 79, 9, 13, 36. So the given the data we are taking here, set up null hypothesis, the occurrence of these digits in the uniform in the directory. Alternative hypothesis, the occurrence of the digits is not uniform in the directory. Here the distribution is uniform under HO. 16 total is 16,200 by 10 numbers. One is missed here, that is 1620. Null hypothesis we are writing here these values here total 1326 up to 0 to 9 10. Okay, 0 to 9 means 10 here. So that is FO FE. FE also we are frequency finding here 1620. 1620. అన్ని 1620లో వస్తాయి FEలు తీసేద్దాం దీనిలోకి వెళ్ళి టోటల్ FE 1200 minus 1620 minus 420. 1785 local 620 is a minus 165, 2278 and 620 is 658, 1540 local 620 is 77. 1543 1620 minus 77, 1290 1620 minus 7 అంటే 620 తీసేస్తాం 1865 లో నుంచి తీస్తే 245, 1642 22, 1992 నుంచి తీస్తే 372, 1279 అంటే తక్కువ ఉంది కాబట్టి మైనస్ లో వస్తాయి 1326 అంటే minus 294, టోటల్ 16,200. 16,200 by అంటే 1620 minus FO minus F naught. The 420 whole square into 1,76,400, 165 into 27 225, 650 అంటే 4,32,964 క్యాలిక్యులేట్ చేస్తున్నాం ఇక్కడ 22 into 484, 372 1,38,384, 341 అంటే 1,16,294, 294 86 436. FO minus FE naught FE square 108 by 99, 16 by 81, 261.2, 3.66, 61.22, 37.05, 0.30, 85.42, 71.88, 53, 53.76, total 711.75. So therefore, the tabulated value of chi-square is 9 degrees of freedom, but it is a 9 degrees of freedom, 5% level of significance 16.92. But the degrees of freedom at 5% we reject H1 because that 9 ఉంది ఇక్కడ 1.16.9 ఉంది కాబట్టి ఇది reject. We conclude that we visit the telephone directory are not uniformly distributed. Chi-square test of independence attribute. The test is widely used in the market research test association between the two categorical variables. For example, association between the age and brand preference, influence of age group on the retail store selection. So let us consider two attributes A with our categories and B as categories. In the table below, the joint frequencies are shown. B1, B2 and BJ are total BS. So A1, A2, F, A1, B1, A2, B1, A1, B2, A2, B2, A1, AIBJ, A1, BJ, A2, BJ, A1, B. So that is FA1, A2, F1 B1, F1 A1 B1, A2 B2, F1 A1 B1, F of A1. So AR is equal to F of A1 B1, F of A1 B2, F of A R BJ, F of AR BS, F of A. The total we are writing here. So f of ai is the number of objectives processing the attribute a1. F of si is the number of objectives processing the attribute bj, and f a bj is the number of individuals processing the both attributes ai bj. Set up the null hypothesis. There is no association between two attributes. There is no association between two attributes. So if the test statistics is given, summation of I is equal to 1 to r, summation of j is equal to 1 to s, f ai bj 0, fi aj bj by fi aj bj, that is whole e. Fi aj bj or the expected frequencies are obtained as below. Pi probability and objective process attributes that fi ai by n, so that is I is equal to 1, 2, 3 and so on are. PBA probability that objective process attribute Bj f of Bi by n, j is equal to 1 to s. Pi a Bj probability that an object process both attributes a Bj, that a b f by a Bi by n under HO two attributes are independent. P a Bj f of a by n, f of Bj by n, f of a Bj expected number of objective process the both attributes are a Bj, n into P a Bj, n into fa by n into fb by n, that fai into Bj by n. So we are taking these values here. So decision rule we are taking here. The chi-square value is less than chi-square of the tab value with r minus 1 and n minus 1. S minus 1 degrees of freedom at alpha percent significance of level. We do not reject HO, and we conclude that there is an association between two attributes, otherwise we reject HO. One example we are taking the following. The tables gives the performance of the 700 students in accounts examination. The students were classified according to their educational background of the intermediate level to see that performance is influenced by the education background test at 5% level of significance. Performance given 4 good, excellent, 190, 60, 82, 70, 30, 70, 300, 400, total given 190, 60, 250. Say it is 270, 350, 100 and 4, 700. Let A I is equal to 1 to Bj, 1 j is equal to 1 to 3 denote categorical variables or attributes and represent education background performance respectively. Set up null hypothesis. The performance of the students is not influenced by their education background. The performance of the students influenced by their education background. Just a minute. So see here another example we have seen here. Chi-square r minus 1 degrees of freedom at alpha percent level. We do not reject HO, and we conclude that there is no association between two attributes, otherwise we reject HO. The following table gives the performance 700 students accounts examination. The students were classified according to their education background at intermediate level to their performance influenced by the education background test at 5% level of significance. Performance, education background, performance, science, commerce, poor, good, excellent, total 196 to 250, 80 to 70, 350. So therefore, let A is equal to 1, 2, 3, 4, and B is equal to 1, 2, 3. Denote that. అంటే ఇక్కడ 1 2 ని ఇచ్చినారు 1 2 రాసాం, ఇది 1 2 3 4 గుడ్ ఎక్సలెంట్ ఇచ్చినారు 1 2 3 రాసాం. Different two categorical variables or attributes represent the education background and performance respect. Set up the null hypothesis. The performance of the student is not influenced by their education background. The performance of students influenced by their education background. A1 B1 190, A2 B2 80, A3 B3 30, A2 B1 60, 270, 70, తర్వాత అంతే. సో FIBJE. సో FIBJEకి ఏమి రాస్తున్నామంటే మనం so writing the value, say this is a 0. So Fi, Fa, Bj, E. So this is the values we are calculating the above from the null hypothesis. So therefore 107, 1429, 150, 42.585714. Fi, Bj minus రెండు తీసేస్తున్నాం 190 minus 1982, 80 minus 50 minus 70, 30, 42 to minus 12, 60, 142 minus 82 point something, 272 and 70, 70. So whole square చేస్తున్నాం 82.857. 6865.306, 70 is into 70. So all these values are find out in here. So these values are we are substituting in this one, that is 176.05. The tablet of chi-square 1 2 minus 1, this is 2 minus 1 and 3 minus 1, that is 2 degrees of freedom, that is 5.99. One tableted value chi-square is greater than tablet value of chi-square. Level of the sickness 2 degrees of freedom, result ఎందుకంటే దానికంటే ఇది 2 ఇది 5.99 రిజెక్ట్ లో ఉంది. Example. A firm is concerned about the high rate of attrition among employees of its sales department. The firm is team randomly collected data along to length of service in the organization and salary 726 employees who have quit the organization. Length of employees the organization was divided into 3 categories: less than 5 years, between 5 and 15 years, above 15 years. Similarly, salary was divided into 3 categories: less than 50,000, between 50,000 and 75,000, and above 75,000. Test whether the salary of employees who have quit their independent length of service in the organization. Length of service less than 5 years, between 5 and 15 years, greater than 5 years, that is 50, 60, 78, between 5,000 to 70, 69, 78, 70, it is 103. Let I is equal 1 to 3, B I J 1 to 3 denote categorical variables or attributes that represents of the length of the service and salary respectively set up the null hypothesis. HO salaries of employees who have quit the independent of length of service. Salary of employees who quit this dependent of length of service is a different one. So therefore f of B values we are writing here 50, 50, 69, 89, 67, 98, 102, 78, 70, 103 we are writing A1, B2, A3. This is we are finding the value, that is 55. We are minusing here minus 5.8, minus 1.09, 4.79, 67, 7 and 4, 98 and 10, 102 and 6, 78 and 10, 67 and 10.53, 70 and minus 7, that is minus 1. Then we are doing the whole square also, we are taking the value here as per the problem. So chi-square level of the 3 minus 1 into 3 minus 1 degree under rows and columns are rows. 3 minus rows mode column mode 3 minus 1 into 3 minus 1 into 3 minus 1 4 we are taking here. Degrees of freedom 9.488. So that is there is also 4 9.8, so we can reject HO. Why? Because we do not reject HO. We did not reject HO. Conclude salaries of employee we have quit from the organization of the independent of the length of service. So test for quality variances we are taking. Test for quality of variances we are taking here. F statistics, if x1 square and chi1 square and chi2 square are two independent chi-square variates with n1 and n2 degrees of freedom respectively, then the ratio of two independent chi-square variates divided by their respective degrees of freedom follows. Snedeker's F distribution and its probability function is given by f n1 by n2 whole power n1 by 2 beta n1 by 2 n2 by 2 f of n by 2 minus 1 1 plus n1 by n2 f 0 less than or equal to f less than or equal to infinity x1 square equivalent to x1 square x2 square equivalent to x2 square, that is v2 we are taking here. So df x1 square comma x2 square we are taking 1 by 2 or v1 by v2 minus e power x minus 2 by 2 x1 square v1 by 2 minus d x1 square into 1 by, that is a v2 by 2 e minus x square by e2 into x1 square into v2 by 2 1 d x square 2. So we are multiplying the same. This one you let us the following transformation of the variables we are taking here. Snedeker f of chi-square by 1 by v1 Snedeker symbols are the 1 by chi-square by 2 to v2. So psi psi is equal to chi-square chi2 square, so that 0 less than or equal to f less than or equal to 0 psi infinity. So this is the condition we are taking the Jacobian transform. J is equal dou chi square 1 and chi square 2 and chi 1 square and chi 2 square dou f by y. So there is a symbol to 1 by 2 2 is equal to f. This is the Snedeker function we are doing. You have to practice here. Applications of f distribution. So therefore f distribution is widely used in hypothesis testing to qualify the two population variance. Test of an observed multiple correlation coefficient. Test of correlation ratio. Test of quality more than 2 means. So more than 2 means we are using the test of quality is more than 2 means we are taking here. F test for equality of population variance. Let two independent samples xi, yj of sizes n1 and n2 respectively have been drawn from two populations, which means mu x and mu y unknown variance sigma x square and sigma y square respectively. X equivalent to mu x sigma square and y equivalent to n mu y sigma square. Set up the null hypothesis. The two samples have been drawn from the normal population with the same variance sigma square x and sigma square y sigma square under the HO. The test statistics is given by f is equal to sx square by sy square. Sx square is equal to 1 by n minus 1 summation of I is equal to n xi minus x bar whole square summation s square y sy square 1 by n2 minus 1 summation of I is equal to 1 to n y2 y minus y whole square. The unbiased estimator of the common variance sigma. The ratios of f follows. Snedeker separation n minus 1 n2 minus 1 degrees of freedom. If we calculate value of f less than critical value of f of alpha percent n1 minus 1 n2 minus 1 degrees of freedom, we did not reject HO, otherwise we reject HO, and when we conclude that the two samples been selected from the populations of equal variance. So in the f ratio, the greater than of two samples sx square and sx square, the taken of the numerator sy square by s square x follows f distribution with n1 minus 1 n2 minus 1 degrees of freedom. So f test of multiple correlation coefficient. If R x1 x2 xk R x1 x2, so f is called sample correlation coefficient obtained a sample size n k-variates. So that test the significance of level multiple correlation coefficient. F test is used and the test statistics under the null hypothesis of the population multiple correlation coefficient is 0 is given by f r square by k 1 minus r square by n minus 1 minus k. Follow f distribution with k n minus k minus 1 degrees of F test quality for more than two population means the test is widely used to design of experiments. The test is the any significant difference the mean obtained in the several populations. Under the null hypothesis, there is no difference of the several population means the test statistics even given by st square k minus 1 by c square n minus follow F distribution k minus 1 n minus k degrees of freedom we are taking here. So set up the null hypothesis. The problem here we are taken here. Two machines A and B are used to make parts which a critical dimension must have the same consistency. The part produced by the two machines must have equal variance. A random sample of 15 parts from a machine has simple variance of measurement 0.014 mm square and independently drawn sample of 12 parts from a machine B has a sample variance measurement of 0.008 mm square. Test the hypothesis of equal variance at 1% level of significance. So variance measurement equal or is unequal we are taking here. This is a 15 we are taking here. This is the 15 n2 is equal to 12 parts s1 is equal to 0.014 ఇచ్చినాడు ఇక్కడ ఇచ్చినాడు s2 is equal to 0.08 ఇచ్చినాడు mm square. So sx square by 0.014 by 0.008 that is 1.75. So that is total 15 minus total ఇచ్చినాడు 15 minus 14 So 15 minus 1 and 12 minus 1, that is 14, 11 degrees of freedom is under just the table of 14.2293. So we do not reject HO in this continuation. So tomorrow from for tomorrow we can discuss from 9.4.5 problem. Okay.